Hello and welcome to all of my combo lords. We are beginning today's stream just hanging out in my bedroom, which, it's been a rainy season around here, both mentally, physically, and actually in terms of rain weather. I just recovered from a sickness recently, and we're finally back to ready to start dropping more frequent content again. But at the moment, not only did I just recover, but it's been pouring rain everywhere. My classroom's soaked. So, for much of today's stream, we may hang out in my room, on my bed here, and take a brief visit to the combo classroom later in the stream. If anybody deeply requests a visit to the combo classroom, feel free to comment something like field trip. And if I see at least a few comments that say field trip, I'll make sure that's part of the stream, that we visit the classroom at some point. For now, I hope you don't mind that we're just hanging in my room. I'm not going to show you my entire room, of course, but here we got my lizard green walls and some equations that I began to scrawl at various points in previous streams, mostly. And today we do have a particular topic I was in the mood to discuss. My streams often are multi-topicked in that we go in and out of a particular topic, weaving it into different mathematical or philosophical ideas or personal stories that I feel the need to share. But I do have one particular, I hate to say, but target of today's video. A particular person's proofs. I'm not targeting a particular person, but I am targeting the research this person is publishing and claiming to the world, and probably claiming to their own students. Because you see, as a hobby, I enjoy looking at false, wrong proofs, looking at ways in which humans like me, who like philosophy and like mathematics and like other things about life, accidentally conflate those two things and put them in some intangible mess that they then believe is some coherent proof. And so most of the time when I stumble across some human creating some wrong proof, I just note in my brain, like, okay, that's something to avoid. But I don't always like sharing it on a stream with you folks because I feel bad. I don't want to target a human. Even if I'm just targeting what they've published, in a way it ends up being a target of the human. I don't want to punch down at any little people who are just trying to figure out mathematics and philosophy and stumbling along the way. Nothing wrong with a wrong hypothesis or a wrong question. The times when I do feel okay sharing it with you folks with no guilt are mostly the times when somebody was so cocky and sure of their proof that they were trying to force it down many people's throats and possibly spreading misknowledge, and B, when the person holds some sort of position of power and it feels like I'm punching upward as opposed to punching downward. And one example is we did a stream maybe, I don't know, some amount of months ago where I looked at some false proofs that a famous actor had published that were saying, oh, 1 times 1 is actually 2. Everything's wrong about arithmetic. 1 times 1 is 2. And we analyzed those to a degree. And normally I have stumbled across many false proofs that I was like, okay, these don't merit me making a stream about, let alone a video or anything. But once in a while I stumble across one that I think is not only comically hilarious, but also negatively influencing society. And I feel morally half obligated and at least okay with roasting a particular person's ideas if I believe these ideas are spreading and I believe the ideas are wrong. If an idea is wrong, I may, take that seed in my own head, but if it's not really spreading, I don't need to spread the wrongness. But if a wrongness is already spreading, there's nothing problematic. Hopefully, I like to be a nice person. I don't like to insult others with me insulting and roasting a particular person's ideas. With that said, we're going to begin by me explaining a bit about where I enjoy looking at false proofs from and how this led me to a rabbit hole of a particular frequent poster who turns out to be an official professor and who has published these silly thoughts in proof-like paper forms as well, and who is still teaching, and whose ideas are so off the map that they're not only trying to convince people online of false mathematics, but I believe they have many students still who they are trying to convince this, because they are currently an active teacher at a university. So, let's dive into what does a false proof mean? Well, if you're a teacher and you make a false proof that's like, here's a trick proof, and then I explain to the class why it was wrong, great. Nothing wrong as a teacher with showing a false proof if you explain the context. And like I said, some people will automatically, accidentally create a false proof if they're just becoming interested in mathematics and philosophy. But if you're that sort of person, remember to phrase it as a hypothesis and not a proof. Proof is a grandiose word. You should strive toward proof being what you put out at some point in your life, not like, oh cool, I had the idea, time to put out the proof. No. If you just had the idea and you don't know where all the strings go, you put out the hypothesis. Now, one place where I have enjoyed sharing some silly false proofs stems through accounts that post on the common site Reddit. Now, there's a subreddit on this site, which is, I don't post on that site much, although there is a combo class subreddit that I need to reply to some more things on. I don't really ever post on that site, although I'm going to try and post more in relation to combo class. But I do use that site to scroll through various subreddits that I find funny. Some people have Instagram or Twitter. Sorry, Elon, I'm not going to call it X. Or Twitter or Facebook or TikTok. You know, obviously all of us have YouTube because I like making and watching YouTube, and obviously you're watching me on YouTube. So obviously if you're seeing this, you probably like YouTube, unless this was reposted elsewhere in the future by an alien. That'd be cool. Maybe you don't even know what YouTube is. Maybe you're watching this because you're an alien. That's extra cool. But in any case, everyone likes having some stuff they scroll through. One of the ones that I find decent at finding funny things or interesting things is Reddit. And one of the subreddits that I'm not sure if I want to endorse or not is just like has some good thoughts. I will more endorse it than non-endorse it, is the main subreddit for math. And I'm pulling this up real quick. This is, well, actually in the background, I just have my graphing software in case we need to, create any wacky graphs anywhere, just in case. Okay, this is completely unrelated to the topic, but just in case we gotta show any wacky graphs, we can totally do those on here as well. Actually, this was the one that's extra crazy. I know this is completely unrelated to the topic, but tell me this isn't crazy. Okay, anyway, one of the places where I know my face is gone. That's okay. We're just sitting in my room. We're going to do the voice on it for a minute. And here we have, but remember, if you want to see the classroom and stuff, comment field trip. I saw one of those comments so far. We got at least one field tripper. If I see 3 or 4 field trippers, we'll head out. Now, here, one of the places that I would more recommend than not is the subreddit for just r/math. And this here, let me actually fix where it's going. Come on. Okay, I really need a tech wizard on here. You guys don't know how hard it is to be trying to do the tech at the same time you're trying to do the entertainer. I just want to be the entertainer. I don't want to be the tech. Okay, so anyway, if anyone wants to move to the Bay Area and help me with tech, I will cut you in on the profits. Okay, anyway, here on r/math, And we don't really have any profits, but I'll cut you in on all the future profits, so you'll have to trust me. You'll have to really like Combo Class if you want to help me with the tech, because I'll have minimal amounts of like money or stuff to offer you, but I help my friends who have helped me with Combo Class will, if I get famous, they'll be famous if they want. And if I get rich, they'll be rich if they want. I already have a list of 5 or 10 friends who, if I'm ever rich enough, they get a house. Now, but we're not going to be that rich probably, because we're going to spend all our money on helping education. I don't care about money. I don't want a fancy car. I don't want a fancy house. We'll spend all the money on making cool Combo Class episodes. If we have any extra, we'll donate it to a school or something. Now, this is the actual subreddit for math, which it is an important prerequisite to the false proofs. You'll see why in a minute. Here, I do endorse this. This looks good to me. These posts on here are questions, the first few I see. This one doesn't have a question mark, but we're not here to judge people's grammar. We're here to judge, if we can understand it, we understand it. These are questions. There's nothing wrong with an intelligently phrased question with multiple paragraphs explaining exactly where the question came from. In fact, all the top 3 are questions. And the 4th is basically a question, but it's not in the form of a question, but it's a ponderance. There's an ad. Go away. No ads. I don't want any ads. Look, questions. These are, and this is a post of some other mathematician's proof. You don't find on this one that the highly ranked things are going to be like, I proved the Collatz conjecture or whatever. Now, many people try to post that on this subreddit, and it turns out that the moderators of this subreddit have a default message that tells them when they see some, like, what is known as a crank in mathematics. Sometimes, I'm not sure what that term always means to each person, so I don't know. That's not the term I'll use. I will use somebody who is confusing philosophy and math in a very silly, foolish way, that we would, just try and hold their hand to their journey if they weren't being so cocky about it. Some people are very, very cocky about some philosophical math thing they've realized. Like the type of thing that, when you watch my videos, maybe you're like, oh, wow, infinity really is different than I thought. Or like, oh, hey, the triangular numbers are kind of cooler than I realized or something. Some people take one of those feelings and turn it into, well, since I felt that, it must mean I'm like the most important person on Earth. And if I just write that in a paragraph, then everyone on Earth will have to accept that I'm the most important person on Earth. So that type of person, the math subreddit moderators tell, no, a normal person proofs that you've written yourself. You shouldn't put on math because that's too low for you. You should put them on what's called number theory. Really, though, they kind of only send the insane posters here. Some people find this subreddit on their own. It's unfortunately named that number theory got it because I love number theory. So I wish it was called some category of math that I didn't like as much. It was like the joke one. But whatever, it got number theory. Now, some people will find this on their own, and occasionally some of the posts on here are someone actually trying hard and actually with a cool idea. But more of the time, these are people who tried to post on math, who the math subreddit moderator said, nope, you got to post this on number theory if it's a personally made proof. And so they put it there. Now, like I've said, many of these proofs are just a random person who's not really, okay, we got to go by the ads really quick. I don't want those dumb ads on my stream. Do we have the audio off on here? Yeah, we have the audio off on the screen capture. Thank Lord. Now, some of these are just a random person who you can't blame them that much that they're just like how about this one? We always like questions. Questions always mean like the person is open to learning more. They don't think they've learned everything there is yet. And so this person saying, where does my short proof of the 4-color theorem go amiss? I'm guessing this person may have just like found this subreddit because it was called number theory. Or maybe the math subreddit people sent them here, but they seem to be more open to possibilities than somebody who says, like, I've proved this thing. Proof of the twin prime. Okay, like, how about this? Proof of the twin prime conjecture. It's called the twin prime conjecture. Now, I get that this person's probably foreign if they're translating that wrong, but you really, if you're going to post a proof of something, should look up the correct name of it. Now, those type of people still, I feel bad mocking them because it's some random person on their journey. But I found one recently. This is one of them. So the account, I don't know why it's called Massive Ad something. Okay, I don't even really know what this means, but it says they have negative 100 comment karma. I don't really know what that means, but negative 100 doesn't sound good. Now, this is one of the ones that I put in the thumbnail because when I saw this, first I thought, just okay, this is kind of hilarious that the beginning of this person's proof about set theory goes Scrooge McDuck. This is one of those DuckTales characters. Let's look up Scrooge McDuck. You know this guy? He's like the rich cartoon duck. He's like, so you know when you're writing a math proof, if you bring this guy into it, usually I'd love it. Like, I'm like, okay, cool. Like, if you can bring this, like a random cartoon character into your math proof, that would be awesome. But they're literally just like saying a scene out of DuckTales and then saying that they prove set theory to be useless. So it's not like they have deeply analyzed Scrooge McDuck's bankruptcy. They make up this random scenario where this is this character from various Donald Duck incarnations that they say he's earns $1,000 daily and spends only $1 per day. Here's another assumption. As a cartoon figure, he will live forever, and his wealth will increase without bound. Okay, so let's take those to be granted to start. Well, okay, first, we're not going to overanalyze this one because it's actually the guy's last post. We're going to come back to this one. What actually happened was when I was looking at this, someone said maybe it wasn't this post. It was a different one where somebody said, so this guy signs off all his posts with regards WM. Now I saw another post that said, oh boy, WM is back. So I was like, okay, wait, does this WM post on this thing a lot? Well, here's the thing. Somebody asked this WM who he is in a comment, and he posted something that at first I wasn't sure if I believed. He said he was this university professor, Wolfgang Muckenheim, who has a whole Wikipedia page in German. So we're going to have to translate this, and we are going to, oh man, I lost the translate thing. How do I translate it now? I like closed the thing that said translate because the stream hadn't started. Now how do I translate it? Oh, come on. How do I translate this? Okay, Wolfgang Muckenheim. We'll go back. Let's try again. Oh, here. Oh, yeah. So remember, translations will not be perfect. And that, like, this article is going to look sloppier written than it is because they're using, like, an auto translator to try and put it in. Like, this is obviously not the thing that actually it tried to say in the German sentence. It's the auto translator is not perfect. But anyway, this Wolfgang Muckenheim, I was looking at it as I'm like, the commenter who's been posting spam all over number theory subreddit cannot be the guy who has the Wikipedia page. But then, okay, wait, this auto translator is really bugging. What's wrong with this auto translator? Okay, anyway, when I looked at his thing, it did say that in his research and okay, wait, criticism's the section I wanted. Can you retrans? Come on. It worked the last time I looked at it. Okay, now it has this is really weird. It has less S's than before. It's like translating it back and forth or something. This was a game I used to do with my friend. I still have documents of this. Me and my like really, really good friend used to look at a sentence we would put into Google Translate, send it to another language, back and back and forth and back and forth. And it would make them really crazy until they hit like some fixed state. We would wait until they went to a fixed state or loop between the translations. It was really interesting. Or some would have a pattern, like a fixed state, but it adds a certain word once each time. So if you did it enough, it would be like the sentence like, I went to the store. If you translated back and forth enough from a language, would either hit a fixed point where it was like, I store went, and it stayed there, or it would be like this back and forth, like it would go like, I store went, I went store. I store went, I went store. Or it would be a growing thing, or it would be like, I went store. I went store. I went store. It was really interesting doing like a repeated translation back and forth. We would just do that. We were like 12 when we did that. That was like when we first found Google Translate. Anyway, I'm going to try again because it reduced the amount of S's when I did that last time, weirdly. So we were going to try again. Okay, now I don't know if that reduced or increased the amount of S's. Okay, we're stuck at this amount of S's, but anyway, we got enough of the section to see that I read that it translated a lot better when I did this before. No, it's back to this. What happened? Where's all the S's? Why? Okay. Anyway, it says, I don't know how to pronounce the umlaut perfectly. We're going to call him Muckenheim, but it's probably more like Muckenheim. I don't know. The umlaut's a little different of a U, like a Muckenheim or something. We're just going to call him Muckenheim for now. Now, it does say he has criticism because his things about set theory, which this particular Scrooge McDuck post was about, and infinity, which his other posts were about, and that post, are criticized by mathematicians. And when I saw this, I was like, wait a minute. This actually is related to the post. When the person was asked who they are in one of these posts, and they said, I'm this guy, either they actually are this guy or they're like copying him in some way, because it's very related. It says this is a mathematician whose theses on set theory have been criticized. And this is some random poster on Reddit who's claiming a lot of crazy stuff about set theory, who says they're this guy. So I was like, let's look this guy up a little more. And when I found what papers this teacher, who, yes, he is still, so this is in Germany he teaches. He is not teaching in the area I'm from, but, RIP to the brains of all of his students out in Germany. He is still teaching classes. He has gotten quite old, and it seems like he has gone slightly off the rocker and is still teaching and is becoming more and more cocky about some crazy ideas. I looked up this man's proofs, and it turns out that he actually published the Reddit post, 7 Contradictions about the Scrooge McDuck, as an official paper. This is an actual paper by a mathematician who is currently teaching at an institution, at a college-type institution. This man is teaching students. The guy who's arguing on number theory with all these commenters, no, you're wrong. We'll go into his arguments in a minute. And trying to spam Reddit with his proofs and arguing with anyone who tries to correct him, has published these things and is currently teaching it to students. So, I suppose today's lesson is also not only going to be a mockery of certain proofs, but a warning not to trust every professor you will have in your life. And, I like to say, you can gauge how much you trust me. I think I'm trustworthy, but I'm not even going to say trust me. You should gauge how much you want to trust me. I think a trustworthy person would say something like that. I think the least trustworthy people are the people who are like, you have to trust me. If you don't trust me, you are wrong in some fundamental weird way. So, We have an official paper that's basically a repost of this guy's number theory post. The thing is, it's not only that he's a professor that makes me want to comment this, but many people are trying to reply to this guy, and he just gets so mad at them. If you write a proof and you get criticism, you can't just get mad at the critic. That's going to show how fragile your proof is to you. If you can't factor in like the best proofs, any criticism thrown their way, the proof maker would be like, all right, let me take a second to think about that. Okay, here's how my proof still makes sense within the frame of that criticism. But anyone who is like, no, we're not allowed to put the criticism on the table or my proof won't make sense anymore. Something a little sketchy there. Now, we can even see criticisms on this like official site where he published them. If we look at some of these things, one of these, he's saying, so we haven't done an official episode about this yet, but a very cool thing in math is called Cantor's diagonalization argument. I'm going to make an episode about this at some point, and it is essentially, I'm not going to over-explain it now because it has a role in an episode I'm making in the future. But basically, it's a way of proving that there's a different sort of infinity if we want to describe all of the numbers on the number line, or if we want to describe things like the rational numbers, which are like all numbers that can be a fraction of two whole numbers, two integers. And so mathematicians consider that if we are going to allow infinity to be a thing, we don't always have to let it be a number. We can sometimes just say infinity just means an endless process. But if and when we allow infinity in as a number-like thing, we have to say that there is a different sort of infinity that describes how many real numbers there are on the whole number line, counting pi and e and all of these weird roots to quintics and etc. And compared to the infinity that's you could say smaller infinity. The nicknames are a countable or uncountable infinity. Now, it sounds very crazy and silly that would ever make sense in math to some people, which is why I would love to make an episode someday, because sometimes I help people understand random stuff like that, hopefully. But the point today is that this is generally agreed upon by mathematicians. Not in every branch of math is it treated the same, but it's something that if a mathematician said there's a deep flaw here, they would have to be very open to a lot of criticism. It's sort of like saying there's a deep flaw in the distributive property or something very almost basic at this point to certain fields of math, or I should say branches of math, because in math a field means something different. But certain ways of looking at numbers, this is considered pretty fundamental and accepted at this point. And if you were to be in those branches of math and say this is wrong, I am talking about infinity as a number, but you talked about infinity wrong, Georg Cantor, well, you're going to have to be open to a lot of criticism, because you are saying that something that has been heavily researched and many, many people have tried to poke holes in throughout history, with people have written books trying to poke holes in this. If you think you're going to poke holes in it with a paragraph, you gotta be open to criticism. So, unfortunately, Wolfgang Muckenheim, the current professor teaching students these things, wrote a paper about the failure of the diagonalization argument. Even on here, on the official site, he publishes it. We're looking at this before we see how he replies to the Redditors he was trying to reply to. You see, like, the top comment that I don't even know how likes or dislikes work on this random site, but you could tell they got 2 and he got none. The post, that's not a good sign if you wrote the proof. And so the top comment is a criticism, and you responded to it, and the criticism got more likes than your response. That is not a good sign. Now, this person's just saying that they're refuting is not the diagonalization argument. They're refuting something that other people don't even consider right. They're refuting a tangential non sequitur. It's reminiscent of that other stream I did where the guy who said 1 times 1 equals 2 was somewhat basing that on the fact that he said everyone's been taught that everyone's been taught that the square root of 2 is 2. And that doesn't make sense. The square root of 2 should really be 1. And it's like, no, wait. Not everyone was taught that the square root of 2 was 2. You must have misunderstood something. So basically, Wolfgang Muckenheim never understood Cantor's diagonalization argument, at least in this commenter's perspective, and which I agree with, and that he was refuting a different tangential non-thing. Like, it's sort of like if I were to say, I want to prove 1 plus 2 is actually 7. Well, to prove this, we know that 1 is like an egg and 2 is like a pear. And when you have a pair of eggs and you break one, then we can't say that it... And at this point, you're like, wait a minute, you're proving or refuting something that's like unrelated to the normal type of math that people do. You can invent your own branch of math, but you can't say that what you're doing is disproving something within a pre-existing branch of math. So, of course, he does not say, okay, I'll think about your criticisms. He's like, he leaves responses, but they are really, really bad responses. These make no sense. In order to establish... Okay, well, we need to read his proof to see what he means by the list. But like here, infinite digit sequences are not real numbers. What do you mean by that? If you put a period, like a decimal point, in front of an infinite digit sequence, it is a real number. In fact, if you have an infinite digit sequence with a period in front of it, you could say that every real number is an infinite digit sequence if you count the trailing zeros, the point 0000 after any real number that doesn't have a different type of infinite digit sequence. Every digit does not define a number, but at most an interval. These things just make no sense. This guy is thinking about things in a very philosophical sense, in that he's had these like weird thoughts pop into his head. Oh, a digit is not a number. A digit is like an interval. But these philosophical thoughts are hypotheses. These should not be retorts to the critic of your proof. So it's for all digits. This is not a good sign to put in a response to a proof. It's not a good sign that you are quoting religion in your proof. Now, I'm not a highly religious person. I'm okay with the people of various religions. I don't mind whatever religion people believe as long as they're nice to other people. But I don't follow any particular religion heavily, apart from comboism, which I will have to tell you more about in the future. And no, it is not a cult. Yes, it is actually something I believe. We will talk more about comboism someday. But anyway, this guy's bringing in God. It's like God means different things to every person. You cannot bring a term that means different things to every person into a mathematical proof. This is, similar to if I said, existence means, like, that doesn't fit in a proof. Or unless I'm saying the existence of numbers. But if I say, like, to be happy, what does it mean to be happy? What is a journey? What is a prophecy? These things do not fit in a mathematical proof. They're awesome to put in write whole books using those terms. Fill a book with this type of thoughts, but don't call it a proof. At least don't call it a don't call it a disproof of somebody else's actual proof within a real branch of math. So, yeah, the guy's saying this thing that when God at the end of times will consider our universe and its universe of sets, he'll be able to count. The, Even people who believe in the same God as this guy probably do not believe this paragraph. This is this guy's very specific ideas about what God means and how God relates to math. I don't even know what God he means. I'm assuming a Christian God, just because that's the most common, but I don't even know. He hasn't even clarified what God he believes in. And he assumes everybody believes in the same God and believes in the same relationship of that God to mathematics and relationship of that God to the end of times, whatever that means, and a variety of things. And something about a less clumsy mathematician. Not very helpful with a proof. A proof is supposed to be about a non-clumsy mathematician. So you don't really need to rant about... Oh, no, less clumsy, I guess he's saying, means the smart... So, yeah, you want to be less clumsy. So, yeah. Would not run... Okay, we'll have to analyze that one later after we look at the papers. We got more stuff and... Now, those are just a hint. He's being a little more polite here about how this guy replies to comments. You see, this guy is not a fan of criticism. And reminder for anybody new, we are not mocking a random human. We are mocking a human who is currently teaching these ideas at a university. Now, looking at this guy's posts, for example, let's look at his comments to see how does he reply to people. Please come back, only having understood this simple matter. The person who replied to him who he replied to there is actually correct on this one about trying to correct him. And he's being so rude. And of course, they all end in regards, WM. So we can ignore that part because that's just like a stamp he puts at the end. But, dude, when you post a proof that nobody believes and you post it to a new realm, now we're posting it on Reddit because nobody believed it before. And you get more critics. Don't tell them, come back after you understand. It's like, bro, how cocky are you? This guy, he says in this one, he's telling the commenter, your proof is rubbish. This guy is so rude, fairly trivial to see that your proof. Oh, he's using my terminology. Oh, hey, WM, I feel you there. I put proofs in quotes in my title as well to reference you, buddy. Nice work on that, proofs in quotes. We got something in common, WM. We like calling what we personally consider fools. We put quotes around when we say proofs. I feel you there, WM, except that when I did it, I'm talking about you. Now, this guy's so rude to every single person who replies to him. But the thing is, if you're being really rude to everyone who replies to you on Reddit, I mean, that would make sense if, like, all of your peers accepted your work, all the other mathematicians in your field or something. But that's not the case. As we've seen on Wikipedia, there is a massive section that we're having trouble translating about the criticism of his thing. If you're a good mathematician, the first sentence of a whole section on your Wikipedia isn't just going to say it's criticized without saying that, like, the criticism's wrong in any way. Just like, it's criticized. And when you write your papers about things like, I am disproving the diagonalization argument that many mathematicians accept, and this one is so... The proof of the existence of dark numbers is one of the main ones I wanted to go into. But there's just so many things here. This guy has failed on a lot of levels. It looks like it was 2017 that he tried to disprove the diagonalization argument. And then it looks like it was more recently that he's done these things. Now, this guy's getting quite old, and these ones could be closer to true than these ones, because I think the guy's getting a little more off the rocker. I don't know. Not all, doesn't happen to all old people, but, you know, sometimes when you get old, you shouldn't be as cocky about your mathematical prowess. Now, this one was saying Cantor is wrong about the diagonalization argument. This one, which, yep, he posted all these on Reddit as well. Posts. He is the type of guy who, he tried to post them on math, and they told him, no, post it on number theory. But there's a lot of proofs. So he goes, shortest proof of dark numbers. The mystery of n segments is like a follow-up. It's trying to reprove the dark numbers thing. Then another proof of the existence of dark numbers. He's like updating it. This most recent one. Oh, no, wait. Game of Billiards. Another one. This is also about the dark numbers. Now, this is either about the dark numbers or about the disproving Cantor. Now, and then, of course, we got the 7 deadly sins of set theory that begins with how Scrooge McDuck proves that set theory is useless. The funny thing, too, is that he claims that this story that he made, based on, you know, Donald Duck's uncle, I think it is. The story he made based on Donald Duck's uncle is, he says, is a simplified version of something that was written by one of the, Frankel is one of the, he says, this is correct, actually. This portion is correct. Frankel is one of the fathers of ZF set and ZFC set theory. Now, this is the quote from Frankel. And obviously Frankel does not think he's disproving set theory because he's one of the fathers of set theory. So I don't get how this guy's saying, I made up a story about Scrooge McDuck. It is and then he says it is a simplified version of what one of the guys who wrote set theory believes. But he says it proves set theory is useless. Like, he must have greatly did he think that the guy who was one of the fathers of set theory, like, secretly didn't believe set theory and, like, snuck in this one paragraph story? He secretly let the world know that set theory was actually fake. And what we needed was the middleman, the, massive ad being, why did he pick that name? Being the name for Muckenheim, our professor here. What we needed was the middleman, the Muckenheim, to turn this secret expose on set theory that was written by one of the guys who invented set theory into a story about Scrooge McDuck, so somehow it can prove that set theory is useless. We also have him saying that the fractions can't be enumerated with natural numbers, and there's a violation of translation invariance and a lot of violations. A lot of violations. And at the end, this is a synopsis of the diagonal doesn't define a number. I only know what he means by that by the fact that he also wrote a paper about the diagonalization argument. If I hadn't also read his other papers, this would be gibberish. The diagonal doesn't define a number. Be like, what diagonal are you talking about? He's lost track of what other people know about him. He thinks like every human on Earth not only will believe his stuff, but has already read all his previous stuff. And his explanation of this is an endless digit sequence without finite definition of the digits cannot define a real number. Very poorly defined, because if you mean an endless amount of digits on the left of a decimal point, that is not a real number. But you can have an endless amount of digits on the right with a real number. They say without finite definition. This is not agreed upon by mathematicians. Real numbers are a whole continuum. There are some that may not have a finite definition. If they don't have a finite definition, they may be a super mysterious sort of real number, but they can still be a real number, just one that's harder to define. But here's where it gets really crazy. So when this guy says that an endless digit sequence can't define a real number, or an endless, just talking in general, when he says about endless digit sequences without finite definition, and that they're not these real numbers, this relates to when he was talking about this thing called dark numbers. Now, this one is so many mathematical flaws wrapped into one, because at first, what I thought this guy was coming from was something very relatable to many mathematicians. I thought he was saying that there are numbers that are what some types of number like this are like non-computable numbers. Non-computable numbers are a number that is very hard to express compared to things like algebraic numbers. There are other sorts of numbers that have been named things like this based on how hard they are to possibly compute. One of the more basic ones being a transcendental number cannot have any algebraic polynomial with rational coefficients that defines it. So pi and e are transcendental. They're weirder than the square root of 2. That one's also irrational. It's harder to define than 2/7. So there are different, very researched and very named types of numbers based on how difficult they are to explain or describe. Here, I was believing he was, thinking about something like that, and just someone who was sort of mixing up philosophy with math and thinking that I'm the first person to ever think about this idea that there are numbers that we cannot describe that must exist. First thing that we know is wrong is we saw in his other paper that he thinks that whatever he's calling dark numbers are not real numbers. So he thinks that whatever these dark numbers are, they're like, not only, we have to change the definition of real numbers. The real numbers are not allowed to be a number line anymore. They're not allowed to be a continuum. They're only allowed to be the ones that we can define. And that anything that we don't define, we shouldn't call a real number anymore, which is nonsensical because the real numbers are the number line. It is a continuum. And we cannot currently describe certain numbers on there. We do not know to what degree we will be able to describe other numbers on there in the future, or to what degree aliens could describe which numbers on there. But if we have a type of number on there, like the non-computable ones or whatever, here to note, the article here is describing computable numbers. I'm talking about the antonym of that, which is, they're not going to have always an article for the thing and the antonym. Sometimes you get the thing and you got to talk about the reverse of it or whatever. We're talking about things that aren't this. But, so, at first I thought, okay, this is very relatable. I've thought that before. Like, I didn't go as far as to say these shouldn't be real numbers, but I've had that thought. Okay, there's something in between. Dark numbers could be a decent nickname if we didn't already have many nicknames for things. Maybe if this guy was a little earlier in history, maybe dark numbers would have worked. That's what I thought at first, but here's what it turns out. He doesn't mean dark numbers in the sense of numbers that cannot be described under some particular mathematical metric. Like an algebraic number can be described with a polynomial with rational coefficients and finite length. That's a definition that I can give that, unrelated to humans, mathematically tells me a type of number. This guy somehow forgot, as a math professor who's teaching students currently, somehow forgot that math is has certain depth to it that's deeper than what humans currently know, and has gotten lost into what humans currently know can be worked into the proof as an aspect of the proof is, what do we currently know? Because when this guy replied to comments, you find that it might be hard to find. He replies to things he's bad at replying to things too sometimes. One time he was like replying to every comment just on the front of the page. But okay, it's just so funny that after this amount of things, you'd say, okay, here's my amount of text. It proves that set theory is nonsense. Bro, if you were going to prove that an entire branch of math is nonsense, it's going to take more than like 100 words. Now, like you could try and poke a hole in the branch of math if you want, but the entire branch is nonsense, he's saying. Now, when he goes here, when he's trying to describe dark numbers, here's where I first found it. What's your mathematical background? He just posts these links to Wolfgang Muckenheim. And these people are like almost not believing him. And I didn't believe him at first until I saw this too. Like German Wikipedia goes into similar nonsense takes of the guy. I could see this being a thing. And this person's right. It actually is Wolfgang Muckenheim posting this nonsense. It's the same proofs that he puts out as proofs. Now, when he comments on some of these, I'm not sure if I'll be able to find these right now. People can find it if they want. But he mentions it might not be this dark number one, because like I showed you, this guy has made a bunch of different things about dark numbers. In one of these things about dark numbers, I remember one of the comments, somebody asked him about what he meant by dark numbers. And when he was clarifying, he clarified that he meant numbers that humans currently don't know. He meant that as humans develop more techniques, which numbers are dark or not dark will change. So dark numbers is not even a mathematical thing to any degree. It's like an anthropological thing. It's like a historical thing. What do humans currently know? But he's saying that it's a mathematical proof. He's tying it into all these mathematical proofs. And at the same time, it turns out that what he really means by dark numbers is a type of number that humans currently can get that will change over time. How is that going to help you with a mathematical proof? If you had come up with dark numbers 100 years ago, you would have you'd have more dark numbers because we knew how to define less constants. So 100 years ago, we could have proved different things about set theory with your dark numbers. I want to find this where he's talking about that he really believes that dark numbers, there'll be less dark numbers in the future. At first I was like, okay, he means dark numbers, like something about non-computable numbers or transcendental numbers or something like that he just doesn't understand that these terms have been nicknamed and researched. But he doesn't. He just means like a historical joke, basically. Now, let me make sure that we are getting all of this stuff on here correctly, right? Because I'm bad with tech. So I'm going to go back to the comments real quick. Cool. So it is all going through correctly. Thank you to everybody who is commenting random stuff. And appreciate all of the chatting and notes and stuff. Now, people are noting how it brings up how it's easy to go too far down a rabbit hole, which happens all the time in philosophy. This is quite true. It happens as well in philosophy, where essentially some people will get hooked on a golden thought that feels really accurate in their head at the moment. But the thing is, I've had many of those, and you got to combine them and mix them with other golden thoughts other humans have had in the past that you read about and talk about, and many golden thoughts you may have over time. You can't always take one of your golden thoughts and be like, that's the one. And if you do, you may need to decide, okay, I'm going to spend a few years since this is the one, I'm going to spend a few years writing or filming or recording something about this. It can't, you can't get your cake and eat it too. It can't be the one that you found something that changes society forever. And you're only willing to write 100 words at a time in an insulting way about it if anyone wants to talk to you and help correct it. So I'm trying to find this one where this guy looks like where he says that they remain dark. Where is the one about dark numbers he was first going off about? There's one of these where he's saying about how that there's a great top comment. Most of the top comments were like, okay, I have to point out a hole in your reasoning. There's the hole in the reasoning. But this one, the guy just, what? This is just shortest proof. Okay, we have to read this whole thing because this guy says this is a proof. This is just absolutely ridiculously silly that this guy is an actual genuine professor who is he's probably telling this to students in Germany. I wish I had the emails or phone numbers of all those students he has or something so I could tell them, do not believe whatever your teacher tells you about dark numbers. So, shortest proof of dark numbers. Definition. Dark numbers are numbers that cannot be chosen as individuals. Okay, we're off to a terrible start. That is not a definition because individuals chosen are not mathematical terms. What does chosen mean here? What does individuals mean here? We need two more definitions, buddy. So, no. Where am I going? Okay. In bed? What the heck was that doing? Okay. Example. This is a weird way of, right? He's trying to say Aleph null, or sometimes known as Aleph naught or Aleph zero, which is, in a way, the smaller type of infinity. That's a really bad way to describe this, but he's saying that all that amount of unit fractions are ones that 1 over n lie between 0 and 1. So this, in a way, is true, but it's a really, really bad phrasing. Then he says, but not all can be chosen as individuals. The heck does that mean? This guy has never defined what individuals or chosen means. Like, chosen as individuals, for all we know, can mean like, oh, its square root isn't natural. Like, what does that mean? Okay, so now we get to the title again. Proof of the existence of dark numbers. Always good to know when you have a paper that is less than 500 words that you've repeated a sentence. That's always useful. Now, okay, let SUF be the set of unit fractions in the interval 0 to x. This is saying the way he wrote it, at least, is we're not including the end segments, but there's a lot of ways to write this. He's writing everything in every language. So we'll just say, in the interval 0 to x, between 0 and x being a number between 0 and 1. Between two adjacent unit fractions, there is a non-empty... Okay. So this is an interesting thought, but it's incorrect, the way that he's expressing this. This is just... He's bringing new things in. You have to define your terms far, far better before you just say, I'm whipping up some new definitions. I'm following a few rules of math that also exist in fields of math that don't use my definitions. In the fields of math that already worked, I'm going to take their rules, I'm going to throw some new stuff in, and the new stuff can't affect the old stuff from being true, can it? No, I just threw in some new stuff. So then when we use the old stuff and my new stuff, I've proved something crazy. it feels like if somebody was like, okay, I'm going to call 1 divided by 0 7. I've now proven that 1 equals 0 times 7. And I built a whole algebra out of that. And it's like, they haven't thought about the fact that if they had called 1 divided by 0 6, they would have built an entirely different algebra out of that. Now, in order to accumulate a number of alpha naught unit fractions, alpha naught intervals have to be summed. What are you talking about? What, accumulate? What do you mean by this? Add? Make a set of all of? What do you mean by accumulate? And then, why are we summing intervals? You're talking about how many points there are. You've never talked... So here's the interval. To accumulate them, whatever that means. So whatever they mean by accumulate is some just weird new definition where we are taking every adjacent unit fraction and adding up the interval. This is just not something that is like related to Cantor's diagonalization theorem or any of the things that he later says dark numbers help disprove. This is more than nothing. Therefore, the set theoretical result is not correct. Therefore, no real number with this can be shown. Those ones are dark. I want to see, is this the one where he says that there's one of these where he replies to it and starts saying the thing that completely changed what I thought about it. At first, oh man, there's a long 111 more replies. Oh no. Okay, we might not find the one I'm describing. If anyone cares, they can go here. You can see the links and everything. But I'll scroll for a minute to see if I can find it. There's somewhere in here where he says that, well, yeah, when we develop new ways to describe numbers, some numbers that were dark will no longer be dark. And at that point, it's like, wait, bro, you were just talking philosophically. There's no math left. You're just talking about what humans currently can do. It's not even philosophical. It's only like anthropologically historical. There's no philosophy or math anymore. They're just talking about, like, what do humans happen to currently know? So, that luckily, real mathematicians, when writing proofs, if you come to a proof, it's based on, even if no human ever existed, an alien should agree with the proof. If you could, describe your branch of math to them correctly, they should agree that within certain axioms, a certain thing is true within those axioms. But, okay, here we're going deep off the rails. Somewhere in here, it became clear to me that dark numbers, he doesn't even mean something like non-computable numbers. He means like numbers humans aren't currently good at describing. Even though he tries to describe it like this here. Now, let's see what the whole paper looks like. The whole paper is basically his Reddit post. It's basically his last Reddit post. But the way... Oh no, I'm so worried about this guy's students. This guy's teaching currently still. Oh. Please remember not to overly trust your professors. Remember, even if you treat me like a professor, that's okay if you don't want to trust me. Your choice to what degree you trust me. Use your brain. Don't overly trust any professors. Because we can see right here that this is a professor who says this is a proof, and if you were just getting into mathematics and you had a professor who was telling you about dark numbers, and they told you they'd written a proof, and you saw it on an official-looking website, and it looks like a whole proof like this, you would probably believe this. But you really shouldn't, because, first of all, he doesn't describe anything. This is another case where he's assuming that people know everything he knows. He's like really forgetting to explain anything. It's like if I started saying like about the card game I'm developing, oh, well, the cool thing is that if plants are allowed to block animals, then this, like, that would make no interesting sense to you folks, because I didn't tell you what the plant cards mean, what blocking means, or what the animal cards mean. So here, he jumps right into people. He assumes that people are thinking about Cantor's diagonalization theorem, and he kind of mentions that in the abstract, but when you look in outline of the proof, it's just like, then we distribute according to Cantor's prescription. Cantor's prescription? It's like, you have to tell the viewer, hey, I'm trying to debunk Cantor's diagonalization argument. Unfortunately, if he described that, that'd be too specific, and all the viewers would be able to say that, no, you are not debunking that. So maybe he thinks it'll help him to be vague, because Cantor has said many things about infinities. So if we don't say that we're going for the diagonalization argument, which he's basically explaining here, the diagonalization argument, but he's kind of explaining it in a wrong way. If you don't say exactly, we are following Cantor's diagonalization argument that I'm actually going to describe correctly, and now I'm going to do I'm going to say why it's wrong after I've described what was correct about it, or that, every mathematician, apart from me, apparently believes works. Not every mathematician. There are mathematicians who have problems with Cantor's work and who think it's weird, it's very paradoxical, and there are criticisms of it, but like I said, to write a good criticism of something so well accepted will take a book, will not take this. Now, but I think Cantor's diagonalization argument is relatively safe and sound within the fact that it's talking about infinity and that is inherently paradoxical to humans. And we're not going to get around the fact that if we want to talk about infinities, it's going to feel wrong. And so we're not going to be able to wrap our head around all of it. How can you wrap your head around all of something that is infinite? It's like practically in the word, it's like not finite. And we're like, but I want to grasp the whole thing. It's like, well, yeah, you want to grasp the whole thing, but the point of the thing is that it doesn't have an end to grasp. There's no hole there. It keeps going. So this guy just kind of feels weird things about that and decided that the paradoxical nature that he feels lines up with a few random math things he came up with to disprove Cantor without even really explaining Cantor's proof that much. If I was disproving this, I definitely would have first done a paragraph saying okay, most mathematicians assume that this particular thing I'm going to set up, that I would describe better than this, works. But I have an exception, and then we will, or I have figured out something different. But I would start with well, the basis that is in the mathematical textbooks is currently this. Now we are going to try and break it. This guy's kind of just from scratch, well, let's throw together Cantor's thing, but I'll show you that while I'm throwing it together the way that I like to throw it together, that it doesn't work. So this guy's, we can't go that in depth into all of this particular one because I haven't done a Cantor's diagonalization argument episode. That will come up because I want to do an episode soon about, I've really been planning that one for a while. It's one of those ones that I have pages of notes about and really should get around to making that's the next episode. But one of the ones that's coming up is about, it's going to use Cantor's diagonalization argument because it's going to be my version of what types of numbers have different types of amount of them. Are there more square numbers than even numbers? Well, natural density, yes. But counting the entire amount of them, no. There's the same type of infinity. But are there the same type of infinity of fractions as integers? And if so, are there the same type of infinity as algebraic numbers to that? And if so, are there the same type of infinity of transcendental numbers to that? And at one point in that chain, we will find that no, we have gotten to a bigger infinity. And Cantor's diagonalization argument will come in handy as a good demonstration of why. So maybe we'll have to come back to this after I've shown you guys the actual smart things about Cantor's diagonalization argument. And then we can see the way in which this guy is basically butchering it. And like one of the comments said, he's disproving a misunderstanding of Cantor's diagonalization argument. It's sort of like if somebody said, hey, there's an infinite amount of prime numbers. And I thought prime meant it has to be a number that I thought prime meant something else. And I disproved that there was an infinite amount of prime numbers. And then the person's like, okay, you've proven something, but it's not related to what I told you, because I told you about something about what I called prime numbers that I hoped you understood, but you are using the word prime different. So you're not talking about the same thing I'm talking about. It's like kind of like how some words have homophones or things that sound the same as them. Like if I say like be and I'm going to prove something about Shakespeare's quote, to be or not to be. And somebody else is like, actually, I'm going to disprove it. But they're proving something about BEEs, like a buzzing bee, like a little bee that stings. And they're like, nope, I disproved Shakespeare's quote because I caught a hornet and it stung me. You're like, you're talking about a different kind of bee. So that's what it feels like when this guy's talking about things like real numbers, infinity, or the types of infinities like Aleph Naught that he was using. What Cantor was trying to do, what it means to be various sorts of number, like irrational and such. All of these things, it seems like Muckenheim, uses the terms differently and is now disproving things about the weird mutant version of the term that he uses. Now, counter arguments. These are not, these are so straight out of his head and not out of mathematical reasoning. In this branch of math, this sentence makes no sense. Finally, the counter argument that in spite of lossless exchange of X and O, a loss of O could be tolerated suffers from deliberately contradicting basic logic. This is absolute gibberish. It is phrased in a mathematical enough way that if you were like this guy's student and you show up to class and you're like, show up to class really tired or something and you're just listening to this guy, you might look at this and be like, okay, this guy's my professor. This looks pretty legit. All these terms are probably just terms that, like, I guess I don't understand that he's probably using correct because he's a professor. No, this sentence is genuinely gibberish. So, I mean, like, it's using things from different fields or branches of math in a way, but it's like a mishmash of like 50 different mathematical and philosophical things into nothing. You can't just be like, well, since I don't know if aliens exist and I like eating applesauce when I'm sick, this proves that the lossless exchange of 2 to 1 makes 3, not 0. It's like just literally along the lines of something like that. This train of logic goes. So here's his translation for all of the German students he's teaching. Like I said, RIP to their brains. Now, yeah, Everyone has a bad professor here and there, as long as you know not to believe all of it. There's bad books too. I endorse reading books all the time, but you'll catch a book with some false information. I endorse Wikipedia all the time, but you'll catch a false bit of info here and there. There is no source that is perfect. So we have to trust all of our sources to varying degrees. But the reason I had to roast this dude so much is that we're supposed to trust professors at institutions who teach mathematics more than average about math. So you're supposed to, out of all the sources, you're supposed to hold a university mathematics teacher at a higher standard than something like your Facebook and Twitter posts. But this guy's stuff is on the level of those, on the level of a Facebook meme or something. Now, this is like, I wouldn't be shocked if you saw that. Yeah, okay. We're done roasting the guy for a second. We may have gone in far enough on this guy, but I just had to take a tangent to show. We'll look through more of this one maybe, because this is this 7 internal contradictions we didn't fully look at. How do I get there? But this is the newest one he's published. And like I said, I just love that. If a paper starts with a math paper's first 2 words is Scrooge McDuck, that is either going to be the worst or best math paper of all time. If they have Scrooge McDuck as the first 2 words of the math paper, you know that either they are proving something in such a new, awesome way, or that they didn't prove anything. In this case, it's the latter. This paragraph would have been fun. I have nothing wrong with this part of the paragraph, but well, why does it have to end with "this proves set theories useless"? For all practical purposes, where's the practical come in? You're talking about a cartoon character living forever and making this fixed, strange amount of money. You're talking about a wealthy duck cartoon character. What does this prove about practical purposes? And then he says that it's a summary of a thing that this guy says. And this guy obviously would not believe what this guy says, because this is like the only correct sentence it's not a whole sentence. It's the only correct 7 words in a row. That yes, Frankel is one of the fathers of, well, it's not even correct. I would have called it ZFC, is what often is quoted as what Frankel is the father of. ZF with the choice. ZF is the one. It's a long story. Set theory is weird. There's this thing called the axiom of choice we're going to have to talk about someday, that it's somewhat paradoxical feeling. It sort of works with or without this thing called the axiom of choice. Some people like it, some people don't like it. And there's ZFC is, related to what degree we accept the axiom of choice and stuff. But that's a story for a whole nother day. That will be far after our Cantor's diagonalization argument. I'm not ready to make a set theory episode, but I will be someday. Now, let's see. Oh, here. So remember last time he said on this post, he wrote a way simpler one on Reddit, I guess, for this. So some of these he fleshed out a little bit in the paper. Like this, you only wrote a sentence or something in the Reddit post for why the diagonal doesn't define a number. But here we get a little more. So why does the diagonal not describe a number? I would also like to remind people that I don't think anywhere in this paper he talked about Cantor's diagonalization argument. He mentioned Cantor's name up there, but he never... Okay, here, it's at the end of the thing. So here he says Cantor's famous diagonal argument, which it's called the diagonalization argument more commonly. Like, here we can see... Well, no, I guess diagonal is... Okay, I guess it's both. Diagonal, diagonalization, so nothing wrong there. But Cantor's diagonal argument, he mentions at the end, and he calls the section, the diagonal does not define a number. It's like, if anyone was reading this in a row and didn't know and couldn't read this guy's brain, he thinks anyone can read his brain. If you can't read his brain and you read this in a row, like, normally you'd read a paper from the beginning to the end, and normally you don't assume that if you want to understand the title of a section, which is supposed to be like the headline, clickbait, understandable, catchy part, you normally don't assume that to understand the title of a section, you need to have read the last word or the last sentence of the section. But if you were going in order, you'd be like, what diagonal is he talking about? Diagonal can mean so many things. And he just assumes that everyone knows that we're talking about, because he mentioned Cantor very briefly there, that this diagonal means Cantor's diagonalization argument that is a very specific, there's other things Cantor did. There's Cantor's staircase. There's this and that. Cantor dust. Those are really cool. Cantor's staircase and Cantor dust. Those will definitely be. Other paradoxes. He was a, prolific mathematician and philosopher. You can't just say his name and just be like, the diagonal. And assume that because he said his name way back there, we know what type of diagonal you're talking about. Anyway, he says an irrational number is the limit of a sequence of rational numbers defined by a finite expression. That's not the definition of an irrational number. It's a little weird phrasing. This is close to correct. I would say an irrational number can be expressed as that. I don't know if I would say that's what it is. That sounds like it's like the definition of it. I'd say it can be expressed in that form. And wait, no, whoa. Something happened very wrong at the end here. Finite expression? Hold up. Okay, so most of you probably believe that pi is irrational. Pi gets lucky because there are finite expressions like the Wallace product, the Gregory-Leibniz formula, and several formulas by Euler. These are no, wait, what is he even talking about? The Wallace product is not finite. This is an infinite product. His examples aren't even true to that. So a finite expression is so wrong. Some irrational numbers can be expressed in that way if you use certain hacks, like you're describing, like an infinite summation. It's not a finite expression. No, you cannot do it in a finite expression. You're using things like a summation or a product thing that are infinite, that are summing or producting an infinite amount of things. This guy is a math teacher, and he's trying to quote the Wallace product is a fun classic thing about numbers. This will make its way into some episodes someday when we're talking about pi. If you multiply this chain of things forever, it turns out to equal pi over 2. Note that I said forever, not a finite amount of times. In fact, this sentence is almost exactly opposite. An irrational number, not precisely the antonym of this is true, but pretty close to the opposite of this sentence is true. An irrational number are numbers that cannot be the limit of rational numbers defined by a finite expression. It's isn't. This should be an isn't. We've gone from this guy being so far off that he's on the side of the field, and you're like, what are you doing all the way over there? To now he's so far off, he's playing for the opposite team. He's gone just to the other side of the team's field. He's just okay, we're going to start saying completely false things about mathematics. How did this guy quote all of these actual results about it and think that they're finite expressions? the fact that you can write them in a finite length doesn't mean they're finite. We're using a symbol to mean an infinite product or an infinite sum. And here he insists that an endless digit sequence without a finite definition of the digits cannot define a real number. Now, even if it was true that irrational numbers could do this, why do we have to say that real numbers are no longer what they were? Real numbers basically don't exist the same anymore. We're saying that the new thing we've invented is not a type of real number that's a new type. We're saying it's not a real number. It's like if I found a new type of cool number based on like a combo of square roots and logarithms. I was like, I found this new cool type of number. It wouldn't be that fun if I was like, oh, and also my new type of number is not allowed to be on the number line. We have to redefine the number line so that all of the what we call real numbers, it now means all the numbers except for my type that I invented. It's not that my type's hidden in there and I found some new ones hidden in there. Mine are so different that now with your definition of your continuum, you need to leave gaps for mine. And of course, let's see what he quotes. We have a citation, but the citation's himself. That's always good to cite yourself when you say a very insane claim. After every known digit, almost all digits will follow. This is like, what is he talking about? It's like if in the middle of a paper I was like, the digits expansion magnifies the number. You'd be like, I don't know what you're talking about, or if you're just confirming what you said, or if you're trying to add to what you said. Now, after all of this amount of text that even included, okay, so it goes false statement, random quotes of mathematicians that don't line up with false statement, citation of self to say something absolutely insane, sentence that really doesn't add up to anything. What does all that add to? All that adds to, therefore, the digit sequence of Cantor's famous diagonal argument does not represent a real number. It's like he hasn't even gone into the definition of real numbers. It's like he has this other idea in his head of what real number means. And he's saying that because of this idea in my head of what real number means, if I find something that I don't think feels real, then every other mathematician has to change their definition of real numbers, even though I didn't really look into the way they're defining it. I'm just, assuming that when they say real numbers, they mean like whatever I'm feeling the vibe of with that type of number. Like, of course I'm not going to actually look at something like whether the Wallace product's infinite or finite. Of course I'm not going to look at what the average mathematician believes a real number is, or how it's been defined, or what axioms it relies on. Of course, I'll just assume that my vibe for what feels like a real number, if it doesn't line up with my dark numbers, then we know that we have to tell every mathematician, everyone on Reddit, and all the students I'm teaching that the definition of real numbers, which I don't even know if this guy knows, needs to change. He has poked holes in real numbers before he has described them. So when he says it's not a real, like if somebody disproves a concept and they don't know what the concept is, you've got to be skeptical. It's like if somebody says I love anarchy, and you're like, how do you define anarchy, by the way? And they're like, I don't know. It's like, well, okay, then you don't love anarchy. It's, if you love something, you love something about it, and you have some hint of a definition that you have for it. So I am going to disprove real numbers. Yeah, by the way, dude, what are real numbers? oh, I'm not going to put that in my paper. I'm only going to put the fact that they can't exist and that they're wrong. No room to put anything about what how they've been defined or what they mean. It really reminds me of like homophones. Like the guys like using just the same word to mean something completely different and then saying he's proving something. It's like within their homophone. It's like if I said like it feels like you ever heard like when you were really young, if you say the word butt like B-U-T in a sentence, and some kids like he said butt like B-U-T-T. And it's like, oh man, that kid proved that you really like butts because you said the word B-U-T as the preposition. And so obviously that kid was not proving anything about whether or not you love butts. So like this guy's not proving anything about real numbers. So thank you to all of our lovely comments. And people are noting, yeah, definitely a very vibe-based paper. This guy, it seems like as he's gotten older, he has not cared as much about to what degree the philosophical quirks line up with mathematics, but he still wants to post them as a mathematical paper. Which it's like sort of a problem. Like this guy feels like he needs to post a mathematical thing and he's like unable to do it right. It's like, bro, just write like a philosophical short story and maybe you'll do a good job. Write a philosophical short story about how maybe infinity is weirder than we think. Maybe some numbers are dark. Maybe this guy would write a good short story, but when you try and put it in the form of a proof, you're gonna get mathematicians like me mocking you a little bit. But remember, I'm not mocking him. I have no idea what Wolfgang Muckenheim gets up to or whether he's a nice fella in real life or not. I got no idea. We are mocking his published papers. Now, also, someone here noted about that it seems like he was thinking of the computable numbers. I think that comment was probably before we looked at this too. But I agree with that comment. We pulled this up even that computables are or non-computables are close to what he means by dark numbers. And the thing is, it seemed like that at first, but then when you read the comments, it's so much more just like, I don't know what word to use other than like anthropological. It's really just, he seems to think about like what tools mathematicians currently have. But he seems to have in his head that the tools that mathematicians currently have represent something grandiose that could be used in a proof. And, you know, it's like, bro, you're old. Just zoom back to your childhood. Imagine if you published this in your childhood. Dark numbers would have meant something entirely different, and it would have proven something different about the real numbers to you. So, yeah, a lot of people like this should take their philosophical thoughts, channel them as hypotheses, or channel them as art, or channel them as funny conversation starters with your people at a party or your friends or whatever. Channel them as, you know, a weird, I wonder if so-and-so, what if so-and-so, perhaps so-and-so. Not, A, I have proven this, B, it disproves all these other mathematicians from history. C, to all the people criticizing flaws in my reasoning, you gotta study more, you're wrong. So, remember, if any of you do feel like you have something that merits a proof to anything interesting, basically, you should be very humble about it and just seek criticism or acknowledgement by showing it to a bunch of mathematical people and seeing what they think. And that can even be on Reddit. You would, you know, some of these, you know, he could have taken constructive criticism from people, but he didn't. And the only case really where you should be so confident about your proof that you're like, I don't care what the commenter thinks, I know I'm right, is like once you've had like dozens of mathematical people agree with you. And I don't think this guy has had dozens of mathematical people agree with him. I have yet to see one. But he's a teacher, and those have authority, and I bet his students agree with him because they want a good grade, and I bet they're, accidentally yes-manning his ideas about dark numbers and such. So, normally I don't come after a guy, but all I'm saying is if I was the Augsburg University of Applied Scientists, I would double. And here's the thing. It says he's been retired, but somebody asked about this, and he says he still teaches extra classes, that he was retired as a main professor at that time, but he still teaches classes every year. A lot of retired professors, it means like, oh, I got on this tenure plan or something, and now I'm not the main full schedule that they schedule my whole load, but they come on to teach a few classes per semester. According to this guy's comments, that's what was the case for him, that he basically teaches a few classes per semester in these times. If I was the Augsburg University of Applied Scientists, I would check in on this guy. There was even one of these on the Reddit where he was like replying to everything very weirdly. He replied to the auto moderator insulting them, and somebody commented to him like, "You're insulting a robot." And he's like, "You're a robot? What?" And they're like, "No, I'm not a robot. You were replying to the robot." And it said on it, like, "I'm an auto moderator. I'm a robot." And so it's like the guy is maybe losing his brain a little bit, because the way he was trying to do comments seemed to be like slipping as well. He was like replying to the wrong things and stuff, to the point some of the commenters were telling him like, "Dude, have you seen a doctor recently? Like, have you checked your head recently? I don't mean this as an insult. I mean this as caring for you." Like, the comments were really trying to be nice and be like, "Hey, can I say, like, as a friend that maybe you should check a doctor to make sure everything's okay with you?" And of course he replied to those in an insulting way, like, "I'm completely healthy. I've been teaching. I'm fine." And so, some people have issues with understanding things. That's not a problem as long as you're not a math professor completely wrong about everything you're teaching and incredibly cocky about it. So, anyway, that was probably enough analysis for today of this fellow. We can come back to this perhaps briefly after I do an episode about Cantor's diagonalization argument, and then we can see even further about like how this guy is not understanding it. And of course, we'll also get some fun things about these in future episodes. I did mention we could take a brief field trip to the combo classroom. So we are going to take a little visit. It's not raining out there right now. Unfortunately, if it's windy, the tree above the desk, like, it has all the raindrops in it from the rain. So if a wind gust comes, it's still going to drop rain on us from the tree. But we'll hope the computer does not get any water on it. So let's take a little 2-minute break, and then we're going to go to the combo classroom for a little nighttime hangout and chat, see how our classroom and stuff's doing, and then I'll put my face on for that part, but we're just going to hang on one of these for a minute. So here, we take a little 1-minute break. What am I doing? Here. You folks read what you want about the Wallace product. Pretty cool. This is not... Okay, that's a boring part of it. It's the proof of integration part. No, that's not what you folks want to read. Okay, how about this? Here, read this if you're bored during the break, because this is very interesting. The type of number that this guy was trying to describe was like halfway between type of numbers that humans don't currently know how to describe and the actually defined thing of this. Now, these are not the only nickname for types of numbers that are hard for humans to describe or that have certain ways they're indescribable, like we've gone over. Transcendentals are a more common type. Now, these are going to be transcendental. I mean, not the computable ones necessarily. The non computable numbers, the ones that are not computable, will certainly be transcendental. So the ones that are not computable is like a deeper version of transcendental, even harder to describe based on certain metrics. So take a peek at that if you're boring. I'm going to pause for one moment and bring us outside. Alright, folks, I'm leading us back to the combo classroom. To any viewers here, I will flip our camera to the class in a moment. And it is quite wet here, so I don't think I can even put the computer down. I'm going to have to hold it here for a moment, but switching to our other source. We are here in the combo classroom. We need to maybe cast a little light if we want to just check how things are going around here. It is quite soaked. Where's the light? It's not letting me light. Okay, there we go. You can see our dice carpet always enjoys when we get a little bit of rain, because the dice get further embedded into our soil. As dice drop and the rain occurs and they get naturally stepped on, they just form this carpet. Someday the archaeologists are going to be like, what the heck is up with this dice layer and clock layer in this part of the Bay Area? But the other parts that the rain enjoys are our staghorn fern sure loves the rain. And over there, we even have this new potato sprout. You know, I left some potatoes. I didn't even plant them. I left potatoes out in that planter bin a while ago, and they started sprouting crazy potato stuff, and it kind of died down. But, oh, no, there's a mosquito here. I saw a mosquito coming. We are fans of almost every animal except mosquitoes. Just, you know. Animals, I like 99% of them. Plants, I like 99% of them. Bacteria, I like 20% of them. We don't like as many bacteria as plants and animals. But mosquitoes are one of the only animals that I'm not a fan of. Now, over there, I don't know if you can see it, but we do. Okay, I'll go over there. Look at this weird potato sprout. Look at this. So I just left a potato in the planter bin. Previously, it grew some crazy things. Those got smushed and then died down, and I didn't water it, so I guess they needed water. Now that it's raining again, some potato sprout thing was still in there apparently, because this just popped up. This is part of a potato plant. To note, this part of a potato plant's poisonous. If I ate this whole thing, I would probably get very, very ill, or die, I don't know, because the only part of the potato that's edible is actually the tuber that grows at the bottom. So we'll eat it if we get any potatoes at the bottom, but we're not going to. If it fruits, it actually will look like a tomato, but that part will be poisonous too. So we're not going to eat anything except what grows at the very, very bottom. Of course, we got our clocks and stuff as well, and all of our other classroom supplies. Now, here we have the tiniest dry spot that I can set down the computer here just for one little mini moment. Okay, using my sleeve to dry this off. There we go. Tiny dry spot to set down for one moment. That chair is soaking wet, so I'll just crouch right here. Anyway, we'll probably wrap up our stream before long, but let me take a peek at all of our nice chatters. Thank you all for joining me and looking at fun random things with me. I'll be back with a lot of more cool stuff soon, because I'm basically better from the sickness I've had the past few weeks. That's part of what made me inspired to say I only like 20% of bacteria. Some type of germ went crazy in me. Well, I don't know if you call that a bacteria or what, but something messed with my system so bad over the past few weeks. I still have a little bit of a cough and stuffed nose, so I'm still like checking with the doctor to make sure it 100% goes away. But we're basically back to normal. We're basically, back in action, ready to get some more fun episodes out. Next main combo class episode, little delay not only from my sickness, but also I like to film with this. My main camera guy, Carlo, and me have a really good role going on the episodes we've been making. And Carlo is out of town for a minute because it's holiday stuff, but I'll be working with him again in 2 days on Friday, and we'll be hopefully finishing the next main combo class episode around sometime between Friday and Sunday. And there'll be other fun stuff to come out as well. Not only all the shorts that I still promised that I have like ready to drop, that I filmed, that I just need to trim and post, but Also, tomorrow is the solstice. The winter solstice means in the hemisphere I'm in, that part of the whole half of the Earth, basically, the longest. Well, maybe this changes in different areas, but I think it's for the whole hemisphere. Is it? Let me see. Is solstice for whole northern hemisphere same? Yeah, so I guess in the whole northern half of the Earth, basically, the whole northern hemisphere, and the southern hemisphere will do a similar but possibly flipped version of this. It's going to be, in this case, since we're in winter, the longest night and shortest day. So days are sometimes more fun than nights. Cool to have the sunlight around. Like, night is cool, but I'm cool with a couple hours of darkness and a lot of hours of sunlight. So it's not that fun when you're at the darkest time of the year. However, the good thing about the solstice is that it also means after that point, every day is slowly getting longer for a long time. And then you get the summer solstice, which is the opposite, where it represents the coolest amount of time ratio possibly, but then every day after that is decreasing amount of day. But it's fun to have cycles. You got to roll around in cycles. You don't want one thing forever. You want contrast so you can appreciate the different things. If we always had the same amount of sunlight per day, then when would we appreciate the seasons? I never used to like fall quite as much, which now I guess we're in winter, but it feels like fall almost because I'm still seeing, right now all the leaves are falling on a lot of trees around my neighborhood, and they're beautiful. They're yellow and red, and normally they're green leaves, and now they're all yellow and red. It's pretty cool. Anyway, tomorrow I may make a little bonus video that I like to sometimes make a little holiday, little bonus video just to thank people and just to wish everyone a good holidays and stuff. And everyone celebrates different holidays. I celebrate a mix of mostly Hanukkah. I'm a little more Jewish. Sometimes Christmas. This year my family kind of did a mix. We gave each other some little gifts at Hanukkah. We might give each other some other little gifts when Christmas hits. We got a little Christmas tree that's a super mini one because it's alive. Like, we actually might plant it somewhere. It's a living tree that's only about this big. Some sort of pine that looks Christmas tree-like. And we got our menorah for the Hanukkah and stuff. Actually, wait, do I still have the menorah out here? Did I leave that out here? Yes, dang it. Okay. We do still have the menorah here as well. And the candles that go along with that and such. So, since I don't follow a singular holiday, and because I don't really care which one it is, I follow whichever ones the tradition kind of makes sense for, but they're all quite similar. Those holidays, as well as others that other people may celebrate. Maybe you celebrate neither of those and something else. Even if you celebrate none of those, a lot of families have some sort of winter ritual where when it gets really cold in the winter, you're like, okay, maybe this is the good time to light some more fires and give more gifts and eat bigger meals or whatever. So maybe tomorrow we'll do a little bonus video just to celebrate the holidays in a general sense without picking a singular holiday, because to me, the good point that represents all of the holidays is the winter solstice, which will be occurring tomorrow. That is a natural thing as well. You know, an alien could look at the Earth and identify that the winter solstice is occurring here. It'd be pretty hard for an alien to look here and, without having a lot of cultural knowledge, know, oh, those lights mean Christmas, or those things mean Hanukkah, or whatever. However, you know, the solstice is a purely natural thing, like a phenomena that occurs in the universe. Now, maybe we'll do a little bonus video for that. In fact, it's been a really long time since I put a normal video on this channel. Maybe I'll do it in video form, just because it's been so long. A little bonus holiday, solstice something. So keep your eye out for that tomorrow. For now, I think that might be all for our stream, but thank you to everyone who joined me. Oh, that's Wild Magic Fellow, our main moderator, OG there, said he was sick as well. That sucks. Yeah, a lot of people got it. A lot of my friends got it. I think it's what they call flu season, and nowadays it's like you have the flu, you have the cold, and you have COVID variations. So, in the past there were various things in the past, but I mean in the recent past, people more often in the fall could catch a cold, could catch a flu, or could be lucky and dodge them. Now it's kind of like you could catch a cold, could catch a flu, could catch a COVID variation, or you could be lucky and dodge them. So, it's a little more sickness going around these days, but it was weird. A lot of my friends got it too, and I wasn't even like at a party with them recently when we all separately got it or something. So, I don't know. A lot of people getting sick these days, but when we're sick, here's what I want you folks to remember. If you're feeling something really bad when you're sick, like my throat is really annoying or like my nose is really annoying, try and remember that later, when you're not feeling that, how appreciative you'll be. It's something we forget. When I'm sick sometimes, I'm like, my nose is so stuffed that I would give like anything for it not to be stuffed. It's so annoying. If it wasn't stuffed, I'd be so appreciative. But then when it's not stuffed, do we stay appreciative of that fact? So be appreciative. If you're sick, store all the annoying parts. And if you're not sick, be appreciative. Take a deep breath. Be like, okay, I have had times in the past where my throat would be itching from like a sore throat or whatever every time I breathed. And it's not happening. So appreciate that. If you do have longer term illnesses, I battle with certain conditions as well. If you do have longer term illnesses, that really, really sucks because those are harder to just like get through and then be at a different state. But good luck to everyone with theirs as well. I have some longer term conditions of my own as well. Now, luckily, we are still a healthy enough combo lord for many, many years of crazy plans. The craziest of yet are definitely still to come. So, thank you all for joining me. I think we're going to pause today's stream or end it and pop back with a little bonus video for the solstice tomorrow. In any case, I love you all a lot, and I'll catch you all in the next one.